All right. So let's review quantum numbers. Okay. Um, so what are the four quantum numbers? What are the four quantum numbers? Anybody remembers? N is the principal quantum number, right? It's the principal quantum number. What is L? L is the angular quantum number, right? Angular quantum number. And then we have ML, which is the magnetic quantum number. And then you have MS, which is your spin quantum number. Is that right? Yep. Okay. What values can N take? So N can be 1, 2, 3, 4, etc. All right? Yep. What values can L take? 0 to N minus 1. What values can ML take? No, minus L to 0 to plus L. What are the two values spin quantum number can take? Plus half and minus 1/2. Are we good? Yes. All right. So if my quantum number, my principal quantum number is 1. All right. What is my angular quantum number L? 0. If my L is 0, what is my ML? ML is 0, meaning it is my which orbital? If L is 0, what orbital is it? S. It's the S orbital. So ML is the 1s orbital. Meaning ML talks about the orientation of the orbital. Does that make sense? Because the orientation is 0, ML is 0. Yes or no? ML is 0, meaning it's the 1s, meaning it's a spherical orbital. Does that make sense? It doesn't have an orientation. And your MS says there can be a plus half and a minus half spin in your 1s orbital. Do we understand the quantum numbers? All right. So if you, yes, got it. The orientation of the orbital. In which, in space, how is it oriented? If it is 0, then it doesn't have an orientation, meaning it's spread evenly everywhere, meaning it's spherical in shape.
So if L is 1,
okay, let's do that. So for my principal quantum number 2, L can be 0 and 1. This talks about the two different shapes of the orbital. Yes or no? Yep. So this, for L equals 0, ML equals 0, which means it's talking about which orbital? The 2s. Because this is 0, because this is the s orbital, right? L equals 0 means it's the s orbital, correct? So that's the 2s, and you have 1 up and 1 down in the 2s orbital. Is that right? So if L equals 1, what are the possible values of ML? Minus 1, 0, and plus 1. Is it minus 1, 0, and plus 1 are the allowed values of ML? Yeah. Which means, which are those three orbitals? Those are the 3 2p orbitals. Because it's 1, what orbital is it? P. It's the p orbital. Is that right? The p orbital has orientation. It has an x, y, and z orientation. Does that make sense? So these are the 3 orbitals that are allowed, and each one of these orbitals can contain how many electrons? 6. Does that make sense? Do we understand it? Are we? So now if it's energy level 3, possible values are what? 0, 1, 2. If it is 0, ml is 0. Because it's 0, this is an s orbital. And there is only one 3s. And it can have 2 electrons in it. The ms is plus half or minus half. But if your L value is 1, it indicates what orbital? It indicates a p orbital. What are your allowed values of ml? Minus 1, 0 and plus 1, which talks about the 3p orbital. Yes or no? If n is 3 and L is 2, it is talking about which orbital? D orbital. If it's D orbital, what are the allowed values of ml? Minus L to 0 to plus L. Minus 2. So what are the values allowed? How many values are allowed? Minus 2, minus 1, 0, plus 1 and plus 2. Those are the 5d orbitals, right? And each one can contain 2 electrons, plus half and minus half. Are we good?
Yep.
Okay, so here is a question, all right? Here is a question. Are we following this so far? So here is a question, and you're supposed to answer the question. You have a 1s orbital. This is a 1s. This is a 2s. And then they have a 2p. And in 2p, you have a down arrow. Are you with me? They're asking you to list all 4 quantum numbers of this particular electron. Shall we do it? Okay. So what is your principal quantum number? Which energy level is it in? N equals 2. Your principal quantum number is 2. If it is in the p orbital, what is your magnetic quantum number? L equals 1. Alright? Suppose I ask you for the ml. Can you give it numbers? Minus 1, 0 and plus 1? Is that right?
Yeah.
So what is your ml? It is 0. What is your ms? Is it an up spin or a down spin? So can I give it a minus half? Those are the 4 quantum numbers for that particular electron. Does that make sense? Suppose I give you an electron in a 3d orbital. Are you with me? This is, let's assume this is the 3d, and I have this electron here in the 3d orbital. Are you all with me?
Yep.
Can you list the 4 quantum numbers? What do you think n is going to be? 3. What do you think L is going to be? 2. What do you think ML is going to be? ML can be 1. What do you think MS is going to be? Positive 1/2. Are we good with listing quantum numbers for a given electron? Do we understand this? Okay, there's one more question. This is on the review sheet. All right? Are we good? Do we understand it? So there are 4 electrons, A, B, C, and D, and they have given you the quantum numbers for those 4, and they say, which of the following set of quantum numbers is impossible? All right? So this is your N, L, ML, and your MS. Such questions will be on the quiz. All right? So I have 1, 0, 0 plus half, and then I have 2, 1, 1 minus half, and then I have 1, 1, 0 minus half, and then I have 3, 2 minus 2 plus half. So it says you have to choose an option, which is impossible. When n is 1, can L be 0?
Yes.
Can ML be 0 and can you have a plus half?
Yes.
There is nothing wrong with this. This looks perfectly right. When n is 2, can L be 1?
Yes.
Then ML can be 1
Yes.
and that can be minus half. This looks like a valid set of quantum numbers. Let's look at C. N is 1. Can L also be 1? So this is not true because L values have to be n minus 1. They cannot be the same. Does that make sense? So these four set of quantum numbers are invalid. Does that make sense? This is your answer choice. For n equals 3, can you have L equals 2? Can that be minus 2?
Yes.
Plus half. That looks valid again. Does that make sense? Do you understand? So you can get a multiple choice question like that, or you can get a free response question where you are asked to list the values of a given electron. Does that make sense? Did this help?
Yes.
Okay, can I start now?
Yes.
Unless you have questions for me. Okay, I'm going to stop recording this and then I will take individual questions. All right?